In this lesson, we're going to take a look at vectors in space. So, basically, we're going to look at vectors in the three-dimensional world, and in this little lesson, we're just going to take a look at a bunch of properties of vectors in the three-dimensional world. And these properties for these 3D vectors are very, very similar to the properties that you find in the 2D vectors. So if you know your properties for 2D vectors, 3D is very similar. Usually it's just adding the z component of that vector. So over here I've listed a bunch of our properties, and we're just going to start by naming which property they are. So first, when we subtract the initial point from the terminal point, it's the same with 2D. We put it in component form, and in component form, the thing that characterizes a vector in component form is these bracket things. Caret brackets, whatever you want to call them, kind of a coordinate, but instead of the parentheses, you have the caret thing, and that defines a vector in component form. Now we have the square root of x squared plus y squared plus z squared, which is pretty much just the same thing as the distance formula, except basically what we're doing is we're finding the distance of a vector in component form, which is also known as the magnitude. And the reason we can just say x squared plus y squared plus z squared is because the initial point of a vector in component form is on the origin, which is 0, 0, 0. So since we're subtracting from 0, we can just say x squared, or x minus 0 squared, plus y minus 0 squared plus z minus 0 squared, and take the square root of that. So you can think of it as the distance formula or a separate formula for magnitude, whichever is easier for you. And then we have here a vector u divided by the magnitude of vector u. And basically what this is going to give us is a unit vector. And what a unit vector is it's a vector that goes in the direction of vector u, except the magnitude of that vector is going to be 1. So we're basically just finding the distance or the length of this vector, and we're basically just dividing the vector in component form by that length to make the length essentially 1 and obtain a unit vector. Next, what we have here is scalar multiplication. And basically what that is we have a vector xyz in component form, and we're multiplying it by a constant c. So basically, we kind of just distribute that constant c to all three terms. We get cx, cy, and cz in component form for that particular vector. Over here we have the dot product, and the dot product is basically pretty much the same thing as 2D, where we have two vectors. We have vector x1, y1, z1, then we have vector x2, y2, z2. I'll get a different color here. And basically what we're just doing is we're multiplying these two, multiplying these two, multiplying these two, and we basically just add them all together. And that's what we have. That's what's called the dot product. We obtain pretty much not another vector, but just a number. Over here we have cosine of theta is equal to the dot product of vector u and v divided by the magnitudes. And what that gives us is an angle between the vectors. And you'll notice this is the same formula that we have in 2D, except we basically apply these 3D formulas by adding the z component in both finding the magnitude and also finding the dot product to obtain the angle between the two vectors. So over here we have x1 over x2 is equal to y1 over y2 is equal to z1 over z2. Basically what we're just finding is that we find that the x, y, and z components are all proportional, which shows us that both vectors are parallel. Alternatively, what we can do is we can plug basically both of these vectors into this formula here, and we'll basically get a value that's undefined because there's no angle between the two vectors as they never intersect. And then finally over here we have u dot v is equal to 0, and that is the same as we have in 2D, which is orthogonal or perpendicular vectors. And basically how we obtain this is that we derive it from this formula, the angle between the vectors. And we know that the angle we want is 90 degrees or pi over 2 radians. And cosine of pi over 2 or 90 degrees is going to be equal to 0. So we get u dot v over magnitude of u and v is equal to 0 when we multiply both sides by the magnitudes. 0 times anything is 0, so we basically get u dot v is equal to 0. The numerator is equal to 0 here. And that's how we get this formula. Let's try some examples now. So the first problem we have here is that we have a vector, we have the initial point, and we're trying to find the terminal point. So first, let's assume that the terminal point is going to be coordinates x, y, and z. Now to find a vector in component form which is given to us, we use basically the formula x minus 0, y minus 2, and z minus negative 3, or also z plus 3. And we're going to make that equal to the vector that's given to us, 6, 1, 4. So basically, all we have to do now is we make 3 different equations. We have the x minus 0 is equal to 6, y minus 2 equal to 1, z minus negative 3 is equal to 4 to obtain the values of the x, y, and z components of the terminal point. So we have x minus 0 is equal to 6, which means that x is equal to 6. Y minus 2 is equal to 1. We add 2 to both sides, y equals 3. Then finally z plus 3 is equal to 4, and z is equal to 1. So 6, 3, 1 is going to be our terminal point. 6, 3, 1. And again, all we did was we used the formula to get 2 points and make it into component form. And basically what we did was we just made 3 separate equations to find the x, y, and z components of the terminal point. Okay, so now let's find the angle between these 2 vectors that are given to us. And the way we do that is first we want the dot product. And basically what we do is we multiply the x components, multiply the y components, multiply the z components, and add them together. So that's going to be 4 times 0 plus negative 1 times 1 plus 3 times 5, which is equal to negative 1 plus 15, which is equal to 14. Okay, so now we want to find the magnitudes of, let's assume this is vector u, this is vector v. We want to find the magnitudes. That's going to be the square root of 4 squared, negative 1 squared, we're going to add that, plus 3 squared, which is equal to something, and then the magnitude of vector v is going to be equal to 0 squared plus 1 squared plus 5 squared. This is equal to 25 plus 1, which is equal to 26. This is equal to 9 plus 1 plus 16, which is equal to 26 as well. Now we have to remember that negative 1 squared is going to equal positive 1, not negative 1. So make sure that even though the coordinate is negative, we're still going to be adding a positive value because we're squaring that term. So now we plug it into our formula. We have cosine theta is equal to 14, which we found here, over the root of, maybe there's some square roots, my bad, the root of 26 times the root of 26. And we can just plug that into our calculator, and we get theta is approximately equal to 57.4 degrees. Okay, so the last one. Are the 3 points that are given to us collinear? So let's assign kind of values to each of these points. Make this P, Q, and R. So basically, if 3 points are collinear, we have a line here. We have 3 points. Okay, so if 3 points are collinear, this is P, Q, and R, then basically what we can do is we can make 2 vectors. We can make vector PQ, and we can make vector PR. And basically, we will find that the angle between them is 0, or the vectors are basically parallel to each other if you put them in component form. So let's just do that. we'll make two vectors. We'll make a vector PQ, and we'll make a vector PR, and then we'll basically see if there is no angle between them, or if they are parallel, and that will tell us that they are collinear, or they all lie on the same exact line. So putting it in a component form, so that's just going to be a -4 minus -2. It's going to be 8 minus 7, and finally 1 minus 4. And then the other line, RP, the vector RP, is going to be 0 minus -2, 6 minus 7, and 7 minus 4. And if we do this, -4 plus 2 is equal to -2. 8 minus 7 is 1. 1 minus 4 is -3. And we have over here 0 plus 2 is 2. 6 minus 7 is -1. 7 minus 4 is 3. And then finally, we just make that into a proportion now. And we basically get -2 over 2 is equal to 1 over -1, which is equal to -3 over 3. Or basically, we get -1 is equal to -1, which is equal to -1. So since it's proportional, we can effectively tell that yes, it is collinear.